Hi everyone, this is section 3.6 of the notes for integrated 3, KC3. So we are comparing polynomial functions. The first thing that we need to start with is the fundamental theorem of algebra, which says that the number of zeros must be equal to the degree, and if you remember, the degree is the highest exponent of a function. So therefore, a quadratic function, which has a degree of 2, has 2 zeros. A cubic function has a degree of 3, so it has 3 zeros, and so on. Okay, so let's go ahead and consider the following quadratic functions. We're going to identify how many zeros it has. So the first graph, you see that it crosses the x-axis 2 times, so this has 2 zeros, right, with multiplicity 1. Second one has 1 0, but it has multiplicity 2. And then graph 3, x squared plus 1, has no zeros, or no real zeros, right, because it doesn't cross the x-axis at all. So, the existence of all real numbers. Now, you hear us say that a lot. So, all real numbers, what is it and what does it mean? Okay, so the existence of all real numbers is why questions always ask for real number zeros. There is such thing as imaginary numbers or imaginary zeros, okay, which we won't cover in this unit. It is also why we state that the domain and the range has to be all real numbers, not just all numbers, because again, there is such thing as imaginary numbers. So, considering that we are only looking at real zeros and real numbers, we're going to consider these two functions. You need to figure out which polynomial has a greater number of real zeros and then justify that. Okay, so looking at this first equation, I have x minus 1 to the third power. Now, you guys already know how to solve this. If we set this equal to 0, we get x is equal to 1. So our 0 is at 1, 0, and it has multiplicity of 3. So this really has 3 real zeros. Okay, for the second function, in my graph, I see that it touches the x-axis. It has a bounce, so it will have 2 zeros with multiplicity 2 for each of those. So this will really have 4 real zeros, which means that the graph has the greater number of zeros at 4 real zeros. Okay, and I showed that the first one has only 3 real zeros. Okay, so your answer would be the graph. Alright, now for number 1, it says what function has an odd degree. Now I know I didn't cover absolute maximum. It says the function f of x has an absolute maximum value. Okay, if it has an absolute maximum, that means that it only has a maximum, no minimum. There are going to be really just one curve, not multiple. So if I sketch this graph, it's gonna be a quadratic with one maximum somewhere. Okay. So if you remember the end behavior of this, the arrows are going in the same direction. So this means that it is a even degree. Now here I have x. I know it's a little hard to see, but it's x to the 4th, x to the 1st, x squared, and x to the 4th. If I take all of these x's together, because they're all being multiplied, and I go ahead and do that, I really add the exponents here. So I have 4 plus the 1 plus 2 plus 4, which gives me 11. So I have x to the 11th in total, which is an odd degree. So the second function would be your answer. Number 2 says which function has a greater number of zeros? Again, counting multiplicity. So this will have 1 0, and this, since it's an exponent of 3, will have 3 zeros, which will give me 4 zeros total. Second graph has 1, 2, 3 real zeros. So the first function has greater number of zeros. Right, and I showed that. Number 3. Number 3 is what key features is equal to both functions. Okay, now the easiest way to do this is to graph both of these. Okay, I already have the first one graphed, so I can see what my y-intercept and zeros are going to be. X to the 5th, I cannot. So go ahead and go on Desmos and graph that. Okay, so if you graph it, it's going to look kind of like that. Okay, it's going to be a little flatter here. But then we're going to go ahead and compare. If I compare the y-intercept here is at 0, the one here is at 2, so it can't be that. Go to zeros, here at zeros I'm at -2, and again it's at 0 here, that's not it. Now this is a 5th degree polynomial. This is a 5th degree polynomial, and this one we can't really tell. The degree is unknown. So the only option we have is the range, which is true. The range for this one goes from -infinity to +infinity, and so does this one if you look at the graph. Okay, so I want you guys to go ahead and try number 4 and 5. I'm going to give you the answer to these, but I want you to pause this video and try 4 and 5 on your own. Okay, so the answer to number 4 would be the y-intercept, because the y-intercept for the graph is at 0, and this, where x is 0, that is your y-intercept, so those are the same. And it is actually the same thing for number 5. Y-intercept is the same, it's at 0, and here. Now number 6, you want to see which one is your positive leading coefficient. Okay, so look at your graph. Since my arrows are both going upward, that means it is positive. My leading coefficient here is negative. And this graph ultimately is going down from left to right, so that is negative. So the function that has a positive leading coefficient would be the first function. And that's all. That's your answer.